Okay, Science 20. Hey, we're back. We're going to just quickly move on from where we were before. So this is where we left off, and you had a couple of these questions that you needed to have answered. So I'm just going to quickly show you what the answers are. Feel free to pause the video so you can get caught up on it. But we should have been talking about this in class as well. Here comes number 5, and there it is. Okay, so looking for the average speed versus the average velocity. Interesting thing to note here, because we're dealing with a change in displacement or a change in position, the speed is just going to be the total distance traveled. The change in position is going to be adding those two vector arrows together. So we're going to get a different number. So this is going to be a situation because we're changing direction. The average velocity and the average speed are not going to have the same magnitude. So that would be what I would suggest for you to pay attention in that one. And then in this one, again, we are seeing a person who is running a certain distance east and then a certain distance west. That's going to give us a small displacement. So again, our change in position and our change in distance are going to be different. And that's going to give us an average speed being different than our average velocity. Okay, so very quickly, I just want to talk about uniform motion. And in uniform motion, basically, what we're talking about is a constant rate of movement. And basically, the velocity is going to be constant. Now, we did some position time graphs earlier, and the position time graphs were all showing uniform motion. In one case, the line was just straight across. I know that's not a very straight line, forgive me. But that would represent no change in position. That would represent no motion, which is still a form of uniform motion. However, if we started at the reference point and did a straight line up, that would be uniform motion in a positive direction. And if we start away from the reference point and move our way down in a straight line, that would be negative or a negative velocity or moving towards the reference point, but it's going to also be done in uniform motion in a constant state. So now the formulas that we were using before, where we were looking at the velocity or speed equals either the change in position or the change in distance over a change in time, that was only for uniform motion. Okay. If we have non-uniform motion, what is that going to mean? Well, that means our graph is not going to have a straight line. Okay. So, for example, let me just quickly erase up here. I said erase. Okay. Just going to put this away for a moment. And okay, so if our uniform or if our motion is not uniform, what we would end up seeing would be curves in our graphs or not having straight lines. Okay, so that's given us a whole bunch of different wiggly waggly stuff here. So we're changing direction, we're changing velocity, all of that. And that is what we're going to be talking about in our next lesson video. So be ready for that. It's going to be a little bit different. But there are a few homework questions that you absolutely should be working on in your textbook. Here they are. Get those done. And if you have any questions, please let me know. Some of you are doing that. Keep doing that. The rest of you should probably be doing that more. But if you have any questions, let me know, and I'll see you in the next video.